It's Mars, and it's home. It's not a dream. The year is 2080. Humanity has survived its greatest migration. More than 120,000 people now live on Mars, spread across 6 major colonies. They eat, work, and raise children under a sky that once belonged only to rovers. This is not science fiction anymore. It's the new chapter of our species. But how did we make it possible? How do humans truly live, breathe, and thrive on a planet that wants them dead every second? This is the story of how Mars became our second home, how science turned impossibility into life. Welcome to Life on Mars in 2080, how humans will actually live there. And before we begin, if you love exploring humanity's future, space, and science beyond Earth, make sure to subscribe to NovaX Space, your gateway to the next frontier. Now, let's step 225 million kilometers away and explore our future home. Mars has been a symbol of wonder for centuries. From ancient astronomers charting its fiery glow, to 20th century dreamers who imagined alien civilizations. But the real journey began in the 21st century, when space stopped being just a government project and became a global race. By the 2030s, reusable rockets, autonomous robots, and AI-based construction systems changed everything. NASA, SpaceX, Blue Origin, and the Chinese CNSA, all joined by private industries and global partnerships, launched the first permanent Mars mission in 2039. They called it Project Ares. It started small, only a few dozen scientists living in metal cans on the surface. But that seed grew into humanity's first colony, Ares Prime. And from there, the expansion never stopped. Through failures, radiation storms, and oxygen crises, humans refused to give up. The early colonists knew they wouldn't return to Earth. But they built for the future generations who would be born here. And now, in 2080, their descendants are the first generation of true Martians. Life on Mars doesn't just change your surroundings, it changes you. Mars gravity is only 38% of Earth's, meaning your muscles and bones grow differently. Children born here are taller, slimmer, and move with a strange lightness, almost a dance. To prevent muscle loss, every Martian wears grav suits, resistance exoskeletons that simulate Earth's weight. It's part workout, part survival. Doctors have also discovered unique biological patterns: bone density management through vitamin D stimulation lights, artificial red blood cell therapy to handle low oxygen pressure, and genetic screenings that track long-term radiation adaptation. For the first time, humanity isn't just visiting another planet. It's evolving to live there. The surface of Mars is deadly. Without a magnetic field, radiation from the sun constantly bombards it. So the colonies were built beneath the crust, 15 to 30 meters below ground. These aren't cold tunnels anymore. They're living cities, carved from Martian rock and sealed in layers of regolith concrete. Inside Ares Prime, corridors glow with bioluminescent lighting powered by engineered algae. Every level connects through airlocks and transparent transit tubes that carry people on maglev pods. Apartments are modular, compact, but elegant. Walls shift automatically to create space. Holographic windows project the Martian surface in real time. Communal gardens filled with genetically modified plants regulate oxygen and humidity. The air smells faintly of mint and metal, a small miracle in a place with no atmosphere. These habitats are alive, not in a biological sense, but in a technological ecosystem managed by AI systems that monitor everything: temperature, radiation, carbon dioxide levels, and even emotional health of the colonists through neural wearables. Mars isn't just colonized, it's optimized for human life. Oxygen is freedom, and Mars never had any. The turning point came in the 2050s, when the advanced MOXIE-3 reactors came online. They extract carbon dioxide, which makes up 96% of Mars' atmosphere, and split it through solid oxide electrolysis into pure O2. Each reactor produces enough breathable air for 10,000 people daily, powered by small nuclear microreactors and solar energy. But air generation alone isn't enough. Closed-loop air recycling systems, using living algae biofilters, scrub carbon and produce fresh oxygen naturally. It's a dance between machine and biology, a hybrid ecosystem that mirrors Earth's lungs. Breathing on Mars isn't just survival anymore. It's self-sufficiency, humans mastering the chemistry of life. There's a saying among Martian settlers, gold is useless here, but a liter of water can save a city. Mars once had oceans, billions of years ago, but now, the real gold lies frozen beneath its poles and deep underground. In 2080, autonomous mining bots extract ice layers, melt them with microwave heaters, and pipe the purified liquid into subterranean reservoirs. A nanotech filtration system removes perchlorates, toxic salts common on Mars, making the water drinkable. This water is reused endlessly. Every drop from showers, air condensation, and even human waste is recycled through advanced bioreactors. Efficiency is survival. The result? Every colony sustains its own closed water cycle, a miracle of engineering that ensures no one ever runs dry. You can't ship food from Earth forever. So humanity brought biology to Mars. Early settlers used hydroponics, but the real breakthrough came with aeroponic towers and gene-edited crops. By 2080, the Martian diet is 70% self-produced. Fields of microgreens grow under artificial sunlight powered by plasma LEDs. Algae tanks generate proteins and fats. 3D food printers use organic paste to create customized meals, rich in nutrients. Perhaps the most astonishing creation is Mars wheat, a strain of grain designed to grow with 30% less sunlight and minimal water. It feeds millions. And lab-grown meat from stem cell reactors provides sustainable protein, without livestock, without cruelty. Food on Mars isn't about luxury. It's about engineering life, one molecule at a time. Mars runs on a tri-energy system: solar, nuclear, and fusion. Solar towers stretch for miles, their mirrored panels tracking the sun even during weak daylight. When dust storms hit, compact nuclear reactors keep everything running. But the real revolution came in 2071, cold fusion ignition. Developed jointly by NASA and the Indian Space Energy Division, it unlocked near-limitless clean power. Fusion cores, buried deep underground, now power entire colonies with no waste. The heat they produce also drives the temperature regulation systems and water vapor generators. Mars in 2080 glows faintly from orbit, a patchwork of lights beneath the red dust, proof that humanity has brought energy to a lifeless world. For decades, Mars-Earth communication lagged by 20 minutes each way. But in the 2060s, the invention of quantum entanglement transmitters changed everything. Now, paired particles maintain instant data synchronization between nodes, a breakthrough achieved by the European Quantum Initiative. Though bandwidth is limited, it allows real-time control of AI, robotic systems, and even holographic messages from Earth. Children in Martian classrooms can now talk to teachers on Earth instantly. Families separated by millions of kilometers can see each other in real-time holograms. It's not magic, it's physics at the frontier of quantum reality. Mars has reshaped humanity's identity. Gone are nations and politics. The colonies operate under the United Colonies Charter, a global cooperative designed to prevent conflict and resource hoarding. Education here is open source, AI-guided, and multilingual. Children learn both Earth's history and Mars ethics, the idea that survival depends on cooperation. Cultural life flourishes, art grown from isolation, music inspired by the silence of the Red Desert, and rituals celebrating soul birthdays, marking the longer Martian day. Jobs revolve around maintenance, research, bioengineering, and robotics. Even leisure is different. Sports like low-G gliders and magball make use of the planet's weaker gravity. But behind the order, there's still emotion. Many colonists describe feeling cosmic homesickness, missing the blue of Earth, the sound of rain, the scent of oceans. Virtual environments and simulated experiences help, but deep down, every Martian knows they belong to a world that's still learning to be alive. This is life on Mars in 2080. Not a fantasy, but the destiny we're building right now. If this journey inspired you, if you believe in humanity's next chapter among the stars, then subscribe to Nova X Space, where we explore how science, innovation, and imagination will shape the universe we're about to call home. Like this video, share it with every dreamer you know, and join us, because the future is already out there, waiting.